Thank you very much. Welcome back to another episode of Indexer Office Hours. Thank you all for attending. Today is the 28th of June, and this is episode 65. Can't believe it's 65. That's so many episodes. That's amazing. So if anyone is new to Indexer Office Hours, I'd imagine we're going to have a few new folks, considering this is a very interesting conversation. We love participation, and particularly in this conversation, we would really appreciate your participation, because we have Alex, who'd like to understand the general sentiment around Substreams. We're going to have an open discussion towards the end of the episode, all about this topic. So please do share your thoughts and ask your questions. Just as a reminder, this will be recorded and posted onto YouTube, so just remember that. And yes, like I said, we have a very exciting agenda today, and I'm very much looking forward to getting into it. So as we always do with this show, we give a shout out to 𝗨𝗪𝗂𝗧, and today is no different. So this episode is episode 70 from Vijay, who is the CEO of 𝗨𝘀𝗧. And for context, 𝗨𝘀𝗧 is, and I'll quote them here, is a company that creates playful projects and protocols for emergent entertainment. So this conversation was very interesting. It was one where Vijay spoke a bit about his background in Web 2. He worked for Google and Microsoft, and then found his way into the Web 3 space. He launched a decentralized search engine back in 2009, which is insane. I can't even fathom what that must have been like. And so he talks a lot about that in the post. Then he goes on to speak about 𝗨𝘀𝗧, the Wonder Protocol, Neo Fairies, and many other DAO and NFT related topics. And so if you're interested in any of those things there, I would highly recommend listening to that episode. So there it is. That is opening remarks. And without further ado, I'm going to hand it over to Anna to take us into Repo Watch.
Hello, everyone, and thank you, Abel. So on Repo Watch, as always, links to release notes and PR can be found in the agenda. And I want to remind you that before we start, we'll only mention the clients that have had releases. And with that, today our Repo Watch is very light. We haven't had any new releases on major blockchain clients. But on the graph stack, on Indexer Service and Agent, we have had a new release, version 0.20.0. And there's two main things you need to know about this. So first of all, in this new version, Indexer Agent configurations by files have been introduced by Kai. Thank you for your contribution. And in terms of the config precedence, which I always find it's very useful to know when you're setting this kind of configs, Indexer Agent will first respect CLI flags. Then you'll be able to override those CLIs with environment variables, and then override the environment variables with configuration file parameters. And then we also have action queue that has been updated. And on action queues, what you need to know is that the Indexer Agent now has 3 management modes. So auto, manual, and oversight. Those management modes you set using allocation management CLI to Indexer Agent. And the auto allocation management mode will act similarly to the current Indexer Agent behavior, where if it identifies an allocation action, that action will be added to a queue, and then within 30 seconds, that action will be executed. If you're using manual Indexer allocation management, then the Indexer agent would not add any items, and instead it will host Indexer management server, which can be interacted with manually, and all of the actions would be manual execution. And the last one is oversight, which requires approver, and Indexer agent will run a reconciliation loop to make allocation decision and add those proposed actions to the action queue. And to run it, you will need to approve it. I'm wondering if we have Ford and Kai, if they want to make any comments about these changes, since you guys have been the main contributors. And also, I'm very interested in hearing if anyone has tried Indexer Service and Agent version 0.20.
I don't know if Ford's on the call, but as far as the configuration changes, the way it's a little bit different as far as the configuration hierarchy. First, values will be taken from the config file. Then if you have environment variables, that'll override any value set in config. And then if you set any CLI options, then that'll override anything from the previous two environment variables and config file. So the goal of this...
So the opposite of what I said.
Yeah, yeah.
Okay, thank you for clarifying.
Yeah, no worries.
Well, I'm asking.
Yeah, no, the goal is to so that we can ship Indexer Agent with a default config for new indexers, so that hopefully we can just say, here, this is the minimum that you're going to need to configure. Here's some sane defaults that will hopefully get you started quickly.
Awesome, thank you. And has anyone tried this new release? I will take that as a no and hand it over to Juan for Protocol Watch.
Thanks, Anna. We'll try to be brief with Protocol Watch, but we only have a few things to cover, so yeah. 𝗨𝗂𝗧𝗧𝗂𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧 I think also has the self-signed vouchers as part of the solution to avoid for some of the inconveniences with the gateway being too strong, basically. Then we have 𝗨𝗲𝗄𝗧, which is the Graph Arbitrum DevNet GAP. There's a new update to the GAP regarding limiting the possible colors of the drip function, as well as now the viability of the rewarding the redeemer of the retriable tickets on L2 with a fraction of the keeper reward. Going into the next GAP, we have 𝗨𝗲𝗄𝗃, which is GraphQL live queries for live data. This GAP goes into detail on how the execution will be, what is the proposed execution, what are some of the changes that are required, for example, query cost, which are, I think, not entirely laid out yet in the GAP, but should be laid out in the future. So yeah, it's not a quite extensive GAP, but it has some detail that will be super useful for people that want to have like subscriptions like data or streaming data, if you will. I think it's based on server sent events for the live queries itself. Then forum research, we have no new updates, and in the contracts repository we have an experimental PR as to how the migration of the subgraphs will go for the L2 scaling solution, because we of course need to migrate the state. So there's a few experimental PRs regarding those possible migration. Yeah. So network subgraphs, we have no new releases. And does anyone have any questions about these GAPs or the PR? Okay, I'll take that as a no, and I'll hand it over to 𝗨𝗀𝗟𝗂𝗪.
Thank you so much. I am very excited to introduce this next section. This next section, we're going to have an open discussion about Substreams, and we have Alex and also Josh as well from Freeing Fast to tell us all about Substream. So if anyone has any particular questions, please do fire away. Like I said, this is an open discussion. But before we do, we'd like to hand it over to Alex to say a few words.
Hello, here are a few words. I thought I would give you a small overview, small recap of what it means, what substreams mean, especially for indexers. And then I want mostly to have you guys like poking with questions. So I'm not going to be so extensive. I'm going to take maybe 5-10 minutes, okay, to cover the big broad strokes. I want you guys to dig in. I know you have, some expected things you want to understand, how we deploy that. So I'm going to give you a brief overview, tell you guys, how we deploy, how it impacts your operations, and then I want questions in. Is that correct? So if I ask a question, I'd expect you guys to perhaps go in the stage chat channel just above the voice channel there and punch in any. It'll be easier for you guys to react there than on the voice, but don't hesitate to react on the voice and punch in your little hand there, okay? Or just interject. Please interject in the middle of the speech. Okay, I'm gonna start half reactions.
Alex, you're dropping off there.
Am I?
Yeah,
Did you hear me well?
A bit robotic.
Hello. 1, 2, 3, 4. I get robotic. Man, that's sad. I'm better.
That's about right.
There you go.
Okay, so tell me when it's better. I continue speaking like that. Is that better? Hopefully, it's going to be better. Always better. No? Yes?
No, actually. I don't know. Is it
Consistent, no change.
Okay, so. I'm trying to then. So in the meantime, then all you guys ask, please, what are the concerns or questions? I have 2 questions on the stage. So, Robot, what do you want to know about Substreams? What do you want to know about Substreams?
There we go. Now it sounds great.
Is it? Does it?
All better now.
Okay,
better.
Well, I didn't change a thing. So you notify me. Okay, so I'm gonna, if there's any issues with the sound, tell me. I'm gonna be watching stage chat here. So Substreams are a, let's say, new way to process data. I made an analogy to a few of you guys. You know how subgraphs are an ETL, it extracts from the blockchain, and then it transforms using this assembly script code people provide, and then it loads it into Postgres and even offers that query layer. So it's a really extensive ETLQ layer. Substreams cut down at the transformation layer. And what does that mean for people to be interacting directly at the indexing layer with nothing being dumped in a database? It means that people will be able to iterate a lot on that layer, indexing. So we're going to be sending queries, even ad hoc queries, to do some indexing. And the output of Substreams are streams of data that someone could decide to pipe into Postgres, pipe into MongoDB, and you'll see we have a sink today to pipe things directly into MongoDB, just as sort of an example that you can use that transformation layer and consume its feed and do some useful things with it. You can think of traders hooking that directly into their trading engine because they would get a real-time stream of things happening being indexed on the fly with no need to transit through PostgreSQL and to do some GraphQL query on top, like incurring latency and sometimes, right, okay. Now, what does it mean? I get a little vibe of what people understand of Substreams in general. So I have the question from Koen, which I can answer, and from Ensign about how centralized and decentralized. So I'm going to address those 2, and you hopefully have other tangential questions. So Koen is asking, the documentation was geared towards developers. What can I do with it? And then you probably, I hope you have taken a look at that. And now the question is, how do I host that? How do I run it, and how do I connect to it? Okay, so the Substreams engine is a flag on the Firehose process. So you -- enable Substreams, and all of a sudden, your Firehose instance becomes a Substreams instance. Now, you might know the shape and form of a Firehose, right? It extracts data from a blockchain. So you have a component extracting from a chain, and then the Firehose server there, which is on the front to the end users, will connect to the back end doing some live extraction, but also, have access to the object store to feed flat files out into a streaming gRPC endpoint. Well, the Substreams engine is queried in a very similar fashion. It is a gRPC endpoint. It is not the exact same method. So, if you know the fully qualified protobuf path of the service, it's not the same. but it looks very much like a Firehose request, except that you're going to be able to pass in modules, and those are the modules that you want to be run against the, let's say, Firehose data, the block data that lives on disk. So you're going to be really doing remote execution of these modules, and they're going to be applied on all of the blocks of the chain. And this can be done linearly or in parallel, which is that new thing. So I'm reading through here. How much storage we allocated for the streaming fast get node. I think that's, will we have to allocate from the for? Sounds gladius. I know it's better than testing with 3 and regards to elimination of regard expects and had a mapping logic safety DDB. Okay, I'm addressing it here. Derek's question regarding to the implementation in the protocol. Derek, do you mean in the graph protocol, or do you mean in the gRPC protocol, how people handle the mapping logic?
Yeah, more within the graph protocol.
Okay, so that's the thing that is to be right now worked on. We're working on these things. We will be able to hook, hopefully sooner than later, the Substreams output. When you have a module that you shape in a form, like you're gonna have the output of a module that looks like database changes. Think of, a table name, a primary key, and some fields that were modified. That looks like a database mutation stream, and we could pipe that directly into a graph node. So we're working on some, sort of not a plugin, but a feature of graph node to be able to suck in Substreams outputs in that fashion, and then dump that in Postgres, and then offer the query layer on top. So that would allow us to go end to end. It would leverage the high parallelization capabilities of Substream, and it would then also, leverage the query layer of Postgres, and also the hostedness, the fact that people host it for you. Because you could imagine that with a stream, when you stream something, well, you need to be the consumer of it, right? When you stream anything, you're the consumer. So it means that you're not deploying that to some other people's, infrastructure. You would be yourself consuming. But if you're putting that underneath a subgraph, or let's say building a subgraph out of a substream, then your consumer becomes the graph node. The graph node also provides the read layers. Does that make sense? Okay. So I'm going to talk to you a little bit. So the Substream EVM chain, but you need to have archive node unlike Sparkle. So there's a question by Kuhn asking, does Substreams mean we can avoid having ETH calls, which we know slow things down? The ETH calls are still available. We made them available in the Ethereum Substream stack. So the Substreams engine is chain agnostic completely. But in the release for the Ethereum Firehose, we have a plugin layer where we can hook into the execution VM for the WASM VM for execution of Substreams modules. We can inject some methods, and that's what Ethereum does with the RPC call, and allows us to do and make ETH calls. So that is still possible. Now there's two things to consider. First is that because you're offered, when you're in a Substreams module, you get in your module the full protobuf definition of the block that you're processing. That means you have extremely rich context. And in the Firehose blocks for Ethereum, you do have also state changes. You have the changes of the contract storage. And from that place, you can actually extract a lot of things that you would normally need to hit the node to get. So I'm studying Uniswap v3 this week, and we've seen that there's a method that was called in their subgraph. It's a change to one of the variables on the contract, right? Some, spot 0 or something like that. But nonetheless, like a change to a variable in the contract that is not emitted through events. When it changes, it's just affected in the storage and it doesn't emit any events. So from an external perspective, you would think you can't do anything, but you do have the storage changes there. So if you know the key that was modified, we can actually avoid plenty of those calls back to the node and requiring their archive node. Because the archive node is the thing that would provide those answers back into the past down to the Genesis block. So to answer the question, it is if you have substreams that still necessitate querying the chain because you have no other means in the past, yes, you will need an archive node. And if you can modify these things to use state changes instead, which I think some of them can be done, well, then you can lower the impact on your archive node, the load. And then there's another thing. The Substreams engine keeps a global cache of all the calls done to archive nodes per block number, per functions. So, and that can be reused, each time you reprocess. So let's say I have a thing that extracts, I don't know, the 𝗨𝘀𝗃𝗀𝗃𝗀 tokens, okay? We have one that does that. And it queries the chain each time. There's a new contract that arrives on the chains to see if it's an 𝗨𝘀20, and then it gives out the decimals and all that thing. And so once we've done it once we've extracted that once, we can actually have flat files that contain that information. So the next time let's say we modify our modules just a slight bit to, I don't know, add some text or whatever, add a new field. Well, the queries will be cached. So that'll be done much, much faster. And that extraction can be done in parallel. So when you do all these calls, you often will have a module that does those queries on chain, and they can be massively parallelized. So they don't need to become the factor of slowness, because if you find that slow, you parallelize more. It'll hit the archive node with more, intensity, but at least from a developer's perspective, it can be satisfactory to have results in less time. And once it's been done once, if the cache is still present on the servers, well, then it can be leveraged to accelerate the flow, even though you're modifying your module there, and even changing the so the cache there is not per module; it's a general cache for an endpoint. So so this means specifically a get archive node, or we can use 𝗨𝘀𝗃𝗀𝗃𝗀. So these ETH calls can be satisfied by whatever node you want. It's not get specific. What is right now get specific is the instrumentation of Firehose to extract the block data. Once it's extracted, you don't need get per se to be in archive mode. Now, 𝗨𝘀𝗃𝗀𝗃𝗀 is also going to be instrumented shortly, so most probably shortly, hopefully, fingers crossed there. We'll see who does that where, but you could use 𝗨𝘀𝗃𝗀𝗃 eventually to do the extraction and also serve as the queries. Now, you might know, you folks, that, I don't know if we announced or talked about it, but because you're in that sort of intimate circle, I'm going to tell you that there's a thing in the works called here the EVM executor, which is based on the Firehose. And it is made to offer a small, tiny service at the end of a small process that serves just ETH calls, and that can be backed by a very simple key value store, which its only purpose is to serve ETH calls. And we have done experiments there. I think maybe, I don't know if Matt is in the call there, kind of connect. I think it's like 280 gigabytes of storage to have a full archive of Ethereum mainnet. And with that, like, it's sort of a small node. You can put that KV store in a distributed storage, like TIKV or Bigtable. It doesn't need to be one process sort of crumbling each time you add more data to it. And it can be sharded on many nodes and all that. And you have that small node that can answer ETH calls. So we have actually a different new implementation of an archive node that would be potentially shareable. It would be based on the Firehose to keep in sync. And I think it's pretty exciting. With that, we would have an alternative to some of the large providers. And it's just great tech to run an archive node. It's detached from one single node, but especially for our purposes to do ETH calls back in the past. So do Substreams have similar immutable properties like subgraph deployments have? So Substreams are totally deterministic. They suck in deterministically produced blocks. Okay, that's the input, a big block. And they have a deterministic, they have a piece of code that is hashed, and they have a cache location that derives from that hashed code and all of its tree dependencies and all in order. So really there's a hash about a module that makes its output deterministic no matter how many dependencies it has on previous modules. And so you can cache those, and you have therefore immutable input, deterministic input, deterministic execution through WASM with a very little, execution environment with not a lot of things that can shake. No random stuff, no stupid things like that. Not stupid, I mean no random things. And then you have deterministic output for each of those modules, and then they can be composed upon, and the whole tree becomes, if not immutable, at least, deterministic. Does that answer your question? Okay. implement if you have other follow-up questions. Does that answer? I had Ensun regarding speed with centralized operating. Okay, so let me pitch in a little bit of the vision I see for answering Ensun question there about regarding speed. How much closer to a centralized operation does Substreams bring the decentralized one? Will there still be room for improvement? Will it be on par with no major difference? So look, there's something really cool that can happen with a large pool of indexers working right now, in competition, but there's an opportunity for indexers to work together. And I'm telling you why. Let's say you have a lot of compute resources. You have 500 machines laying out in the dust and you don't know what to do with them. Then you can bring them to the network so that people can do rapid parallel operations. You'll need to have the data, but maybe you don't have, the time to process all these chains, so you could buy the data from other indexers that have taken the time to process some of these chains, or buy pre-indexed things, because all these indexes, all these modules, they can be cached, and they are cached to disk. Once they're processed once, you've done some work there, well, you can flush them to disk, but you can also give it to someone else who would want to build perhaps upon that module, or just serve that data faster to their end user who are requiring that data, but they have not processed it. So instead of them, like indexer B, processing it all, it would buy from A and sell to B with a small margin. And there's a whole ecosystem of things where people can still collaborate. And now it makes it so the sum total of all the indexers working together, holding data for, not even holding all for all the chains, but holding data for 2 chains here, 5 chains there, and then those modules here and those modules there, and someone providing compute resource and some less who have a strategy of just holding more things on disk and caching so they can resell and offloading their compute work to another guy who has, has a more compute resource. All of that can become something larger as a sum total that perhaps one entity would like to bear itself, right, with the whole thing. So I think that's really exciting. I see that coming as an opportunity for us to collaborate and make the sum total greater than, anyone would actually want to do. Because there's, reusability of the data. Does that answer the question, Ensun? Let me review that question there. No major difference. So I think in the end, it could be a major difference. Yes, and then data replication could help secure. There's a question of security there. So what does scaling of query volume and subgraphs look like? Now there's one thing about substreams queries is that all of a sudden the development flow and the production flow may look just like one and the same. Someone who's modifying his module to iterate and stream segments of the chain actually looks pretty much like a production system streaming segments of the chain. You just don't know what people are doing with it in the back end, right? Are they storing it in a production warehouse, or they're just seeing it on their screen with pipe less and scrolling through the output just to. So why do I answer that question? Scaling volume. So all of a sudden the developer flow becomes also a query stream, and you can imagine that developers iterating will want or need or have to pay and will pay for the infrastructure that it costs. And if they want a lot of speed because they want a lot of parallelization, well, that will mean pricier development for them. But at the same time, maybe you can choose whether we can have eventually a signal saying, okay, I'm going to iterate on that. So don't cache it on your servers. Don't waste space for that. And at some point I might say, okay, this is a final module. I'm going to publish that. So if you want to cache it, maybe there's an opportunity for you to resell that data 5 times or 10 or whatever, because it's going to be shared and a lot of people might want to build upon it. So there's some dynamics that don't exist right now in terms of, closeness of dev flows versus production, which might change the scaling of query volume. But you can also imagine a whole new market segment. Now, I'm telling you, the developer can do some modifications, send stream, and there's a lot of horsepower that can be deployed there to process the whole chain in 5 minutes, if want be, right? Depending on the module and how parallelizable it is and how many layers there are in those stores being built, because the store needs to process in parallel, but then need to be fused together before the next stage is started. So there's a little bit of delay that can be incurred there. But if you have simple things like you're scanning the whole chain to get some certain events, well, you actually could be parallelizing down to the block level. And so that means maybe there's a new opportunity for people to be building ad hoc queries very similar to BigQuery. And that really potentially changes the game in the sense that you'll be serving just a broad new ecosystem of players, people wanting to do ad hoc analysis of what's happening on the chain, going in the history, segments, building modules that are not going to be streamed forever, but just once. And I mean, so that could scale query volume directly on Substreams, and Subgraph would be something more for, you know, production, where you have finished iteration. You're not doing ad hoc analysis that much, but you're feeding into Postgres to be queried on the GraphQL layer. Does that answer any questions there? Okay, I'm gonna open the floor.
And if anyone in the audience has any sort of questions, either you could post them on the stage chat and then we can pick them up, or if you want to raise your hand, we can invite you to the stage and ask your question. So feel free to do that.
So, Alex, first off, thanks for the introduction. That's awesome. I had a couple of questions as far as the resource requirements for a streaming fast node. Is that even the right terminology to use here?
Yeah, it's a good question. So you use that terminology over there, a streaming fast geth. So this is more of a firehose question. Where's that question there? So there's no such thing as a streaming fast geth node unless you mean an instrumented geth node, right? So an instrumented geth node to produce block for the firehose, they do not need any more storage than a full node. It's just a full node with a mode activated on it that will spew out everything that's happening during execution. So we can have that data to be consumed later on without the need for the geth node to be running. We've extracted all of the data. It's now in a file. We don't need the geth node to be around when we want to query its data anymore. So the storage for what you call a streaming fast geth node is just a full node. And that's the same principle for all the other protocols, because the goal is just to instrument real time what's happening when it's executing those transactions. We never need more than the simplest node that is provided by the protocol. In case of Ethereum, that's the full node. But you know, it could be a prunable full node. It can be a thing that would never be able to answer any JSON RPC queries because its goal is solely extraction. So some protocols even have inside, for example, the geth node or their node, indexes to help with querying all sorts of different things. Well, all these things can be disabled. Like all the number of things that this node needs to be can be shrinked because it has just one responsibility: extract upon execution. And so on different protocols also, you need to make sure that is the node that does execution so that you can see these state deltas happening. You have the previous value, you have the next value when the execution occurs, right? So that determines which node, the size of the node, but most of the time it's just the simplest node you can get that can do execution on a protocol. Does that answer the question?
It does. So it sounds to me more like what we're running when we're running a streaming fast, an instrumented geth node is really a block ingester, and then that dumps everything out to the disk then. Do I understand that right?
Somehow. Yes, actually, exactly that. So that's the firehose aspect of it. Substreams build upon that in the sense that it's going to read those files and then apply some transformations on them, like provided you send out that WASM code. So that's what it does. Like you can think of the Substream as a stupid WASM engine, receives one block at a time, a protobuf of the block, of the next block, as bytes, then the code decodes the block as, protobuf, and it can even selectively decode some parts of the block to be more efficient, and then does something with it and perhaps creates another protobuf object, which is going to be the output, serialized as bytes. So your transformations are literally bytes in, bytes out for those mappers there. And they're at that, further down the pipe. The substreams are not concerned with geth or closeness with geth. Now, maybe there's a thing to clarify, is that these nodes that you call streaming fast nodes, which geth node instrumented made for extraction, we usually don't use them to query ETH calls. Someone could want to do that and make it its archive node, also the extraction node. I don't think it's useful because you want to keep those nodes like really simple and easy to flip flop and restart and whatnot. But it's a different concern because running substreams, you might need an archive node around, but it would not be the instrumented node. You would need to have an archive node for that protocol somewhere else to receive the ETH calls separately. And that's a different concern than the instrumented node, if that helps in any way.
Yep, it does.
Okay. What might be a path to verifiable indexing and queries look like with substreams? So look, I'm not a pro with verifiable queries and verifiable indexing. I'm not a pro with that. Though maybe I could just jot a few ideas and you can build better things around. So, the output of all these modules, substreams modules, is deterministic. We want them to be deterministic. Therefore, they can be hashed, they could be voted on, they could be asserted economically, right? If I have 5 indexers and everyone signs a block extracted from the fire hose and signs them, maybe they can convey economic security. There's a game to be played there if someone receives that and can compare it to other folks who have signed something different. And then maybe there's a game to be played and say, look, I'm myself even going to go claim to the chain that someone has signed something that was wrong. I have $10 million voting for that and 5,000 here, and I could do some game there. Now, same thing would apply to any substreams module because they all derive deterministically from the fire hose blocks. Same thing could happen down to the end of the stream. The substreams is really similar to the fire hose. It's actually based on that technology. So what applies to fire hose mostly applies to substreams in most cases. And so if we solve, verifiable indexing and queries, now queries, I think there's more to queries when it's done through Postgres because there are all those transformations. So I'm not sure I'm the best person to answer precisely there.
I think to jump in there, at least in the first instance that Alex described, where substreams are being piped into GraphNode, where essentially, which is where I guess the most thing has been done around verifiable indexing, verifiable queries. I think PIs will be generated in the same, well, if not in exactly the same way, but in about the same way as they currently are. Before they, I guess, land in the Postgres database in GraphNode. So substreams derived subgraphs will have all the same benefits. Right. When it comes to substreams as a native citizen on the network, that's obviously a wholly different discussion. But there's a bigger can of worms there.
Exactly. Sorry, maybe I misunderstood. If it's going through subgraphs, then as Adam said, not a lot of change here. Okay, I'd like to have other questions. I'd like to understand what you guys think, you guys indexers in particular, what do you guys think about, the burden or the opportunity to get a larger market, but also, it's a different shape and form of the infrastructure. Is it too much complexity, too fast? What do you guys think? I'll give you a minute there. Holy Christopher Bram, Gabo, Chidubem. Go interject.
So Alex, I guess one thing that I know we've talked about, one of the appeals of substreams is the ability to, I guess, scale resources. And I know you guys in testing work with quite flexible setups. Obviously, indexers have different setups. Some people are using Kubernetes, and I'm probably quite a similar setup to streaming files. Others are more on bare metal stuff. So I wonder if you could talk about that, and also because it's not it won't necessarily work out of the box in all those things to start with. So
true. Very good question. I should have talked about that earlier. So the way I told you it was just this fire hose with a flag, and that is true for the simpler setup where things go linearly. So if you have that fire hose is already set up and it's already serving queries and you understand that part, then enabling the flag will enable that service to merely receive the modules and start from the start block of the module definition. A module says, let's say a Uniswap starts at that block. It's going to start at that block and process things linearly for you. In which case, you're not going to get so much of the you won't get the parallelization benefits. You will get some other benefits, but not those. Now, if you want to enable parallelism, you'll indicate to that fire hose a pointer to a bunch of other nodes, which are the same service, the fire hose, or we call them here the substreams tier 2. And there are a bunch of other, in our Kubernetes parlance, there are a bunch of other pods, and they will receive chunks of requests. And then so we have the first one on the front, the fronting, fire hose receiving the Substreams request. And it's going to cut that request in 1,000 smaller parts and orchestrate them, those queries, into a second tier backend. That's where your compute resources are, put to the work. And all of these pods are stateless, because all of them point to a single object store. Think of NFS, Azure Blob Storage, S3, a Google Buckets, or, a CAF or a GlusterFS thing. Just storage, object store, files, basically. And because they all point to the same, the work they're doing is contributed back through that storage to the service that is waiting to send responses to the end user. You have that fronting, fire hose, and then you have tier 2 fire hoses, and that's where things can get more flexible. You could be asking those requests to tier 2 Substreams engine from another indexer, or from your own pool of resources, or eventually from, even an automatically routed engine, which would go to where people have caches of what you're trying to build. So maybe they can send you the data faster. And all that sort of routing engine of where are the resources, where are the caches, where are the CPU resources available for me to give an answer to the end user faster at a price that we've agreed on, well then that can live in that orchestration layer. But basically it's fun that those instances are stateless, that they don't need like complex synchronization mechanism. The synchronization mechanism is the object store, and we're trying to keep it as much as possible like to be that simple. Does that answer the question there? Okay, so Jim asking, what's the CPU, disk, and memory should be available to get starting? Lots of just reclaims. Okay, let me read the question properly for those seeing. So he says, I think indexers want to understand what CPU and disk and memory they should be making available to get started, contributing to the testing of first the Firehose and then the Substreams. And is there a one-stop shop doc that covers deploying Firehose, for example? So we have admin guides in the docs at firehose.streamingfast.io. They are not extraordinary. We want to make them better. You can go to the Indexer Firehose channel in the Graph Protocol Discord. There's a bunch of people who went through that. We are there. We're present. We can help. And we'll very much appreciate and give you all the help you need there live. And also use that sort of live feedback to build better documentation. Okay, still, there's not... okay, you have it there. That's a one-stop shop. Now for resources and CPU and disk and memory, that'll depend on the chain because, the size of those blocks vary a lot. Ethereum, I'm thinking Solana, those blocks are just much fatter and there's more data flowing, so you need more RAM. CPU-wise, you know what? In our analysis in these systems, the costs end up being represented better by the bytes read. And we want to do more research on that, but it's the presupposition from the comparison to BigQuery. BigQuery bills people based on the number of bytes that is consumed to cobble up your query. And it seems that the number of bytes you're reading is going to be the factor that will drive your cost structure, right? If you're reading a lot of things, it means you're going to be a lot of CPU, and it means there's going to be a lot more memory. But we can have a sort of multiplier on the bytes read to figure out. Now, that doesn't help very much to size it today, because that obviously depends on the number of queries you want to serve. But I don't know. This is runnable on a laptop, right? You can run on a laptop. You can even download Firehose blocks, and people are doing that. You download the Firehose blocks to your local laptop. You run a Substreams engine on top, and so you're doing everything locally. You can try to debug, and that runs on my machine, runs on anyone's machine, even in parallel, right? I spin 40 requests in parallel on my laptop, and they get squashed just like they would on production. And on production, we had 120 queries in parallel with, 16 pods, 20 machines, something like that. I don't know. The shapes and that is yet to be defined. I don't know. Open Ethereum using ending capacity to start doing something, reclaim huge amounts of fast storage. Right. Well, the thing is that you don't need fast storage because you're plucking from an object store, streaming the data out of there, putting it inside of that, WASM machinery. spewing out outputs that you might stream to the end user, or flush back to slow storage. Because you can do it in parallel, well, reading many, many more files from object storage can become really, really fast, even though it's not on fast storage. And we don't need fast storage because the files are useful in their entirety when we read them. When we have a module that's been cached and we want the module's output, we don't need fast, lookups of random memory access. We load the file and stream it out, the whole thing. It's very linear. So we don't need fast storage in that sense for random access. Most of the files are, buckets. I don't know if that helps, right? But that's a good question though, because the type of storage you need is much less of a costly type of storage. Same thing for Firehose, right? Rarely are people going to go and read the first blocks, so they can even eventually be optimized and stored in some even cheaper storage that can be slightly pricier to go fetch, and you could even pass down that cost, so that you don't have long-running costs of old history, but you have a cost that makes sense. So you could put things in a Glacier, or I don't know what those optimized storage, or have your own solution of spinning disk that are much cheaper. And the interesting thing is that the cost for that has been optimized like crazy a lot in the past 30 years. Bottleneck usually is for Firehose, Substreams. Sometimes we'll hit out of memory, right? But otherwise, that's what I want to see. I want to see larger usage so we can try and see what's the bottleneck. Like, it's not been network. It's not been, I don't see a lot of bottlenecks yet, right? So I want to get to that. We have OOMs, we bump the memory, more memory, then we continue on, right? CPU, we could put as much CPU as we want because we can parallelize stuff. So, okay, I want some other feedback there. I'd like to know what you guys are excited about, are not excited about, your concerns, your critiques, your insults. Please bring them on here. Townie, what do you have to say, man? 𝗨𝗀𝗂𝗧𝗶𝗀𝗀 Atlas. Real Chubby, you have not spoken. You raise your hand. Stefan. Who's there? Jack Rabbit. Graph Knight. Come on. Okay. Chris. I know what you think, Chris. What's the strategy for maintaining EVM instrumentation required to make Firehose and Substreams work across so many blockchain clients? So interestingly enough, it is a valid concern, not only for EVM instrumentation, because there's not 75,000 of those, although there's many chains that derive from the same implementations. But this is even more a challenge for different protocols, because there you need sort of deep down, maintenance of the different protocols, which you can't really easily, share the mental model or understanding. Whereas with, okay, required. But for EVM, just to wrap that part, like we're seeing Aragon, the BSC is going to Aragon, some other going to Aragon. We instrument Aragon, we have 7 chains, 10 chains. And when we have Open Ethereum, we have 10 chains and all that. So the number of, in EVM land, because it's reused a lot, the number of implementations can be quite less for a great gain in chains. But the strategy is to, you push into it. Ideally, we would have recognition of this ecosystem and this sort of hugely powerful indexing pool of resources with pre-cached data, with streams of modules of like data that's been abstracted and made into more refined and more useful construct through Substreams modules, and that could attract more people consuming that, and therefore have the eyes of the protocol implementers turn and say, look, if I want to have all that crazy power, all I need to do is maintain a Firehose output. And really it's just, taking the blockchain model, the data model of the protocol that they know, transforming it into a protobuf and spewing it out through standard output. So ideally in the end, that would be, in the protocol implementers, turf to maintain, and then we just get the benefits out of that. Does that make sense? Ideally. And now for the time being, we do the work, some people do the work, teams do the work, people interested in those protocols do the work and maintain it going forward. If Firehose acts as the extraction layer, where substreams act as the transform and load layer. Is there a future of multi-chain transformations? So just want to clarify, substreams do not act as the load layer. They act as the transformation. The output of that is a stream. And what's interesting is that all of a sudden it opens up the possibilities, people contributing or paying the network for those streams to output things in many, many different places, to have thousands of load layers. And I'll give just a few examples that got me excited, that we can easily load that into a Kafka queue and get the ball rolling with complex infrastructure into Apache Spark. We could get these things going into RabbitMQ or whatever IoT other thing that would consume, and that would be the load layer. You could have a thing that loads it automatically into an Excel spreadsheet based on the stream, right? But we could also have sinks like that. I call them sinks, S-I-N-K-S, like a data sink. And then you would have like a data model in the substream that is a Slack message, and you would pipe it to a sink that is a Slack message publisher, and anything from that stream would just end up into Slack. And then all the other messaging services. I can think of sinks consuming substreams data, and they would load it into, a messaging service. And now all of the databases are obviously great and easy targets. You format the data at the outset of a substreams module, you dump it into Postgres, MySQL, MongoDB. It could even be transformed into the replication protocol. Think of a Postgres, master to slave replication protocol. Maybe the substream becomes that, and it pipes directly into the slave's input, and the database is synchronized in that way. That's possible outcome. So, okay, just wanted to say that the load layer is not implicit in substreams, but it opens the possibility of many load layers. Now, for the multi-chain transformation, we have the same challenge there as to how do we clock that. One interesting thing of substreams and what makes it very different from Kafka or other, large-scale systems like that, is that it is clocked. That is what allows us to have modules that are composed within one block, because they all are clocked together on a block number. And also what enables parallelization. So we have boundaries in the clock stream to, adjunct things, and we know that that doesn't exist in Kafka or other streaming engines. There's no clock. People just think of Kafka, people put click streams. There's no clock. It's just the time of day, and it's so less easy to synchronize many events occurring on different places. The blockchain does that for us. So that's one great thing about substreams. But now if we could have eventually something to clock multiple chains, then we'd have an opportunity to have substreams be clocked in a deterministic way. And that is also things that we're thinking about for subgraphs, right? Is not. You have to stop me, guys.
Yeah. Just to dig into that, Derek, I don't know, because this is something we've talked about and debated quite a lot internally in terms of the clock and what it would look like. Could you, I guess, elaborate on use cases a bit more? Because I think that there's a nuance as to whether you are essentially if all of your data from different chains is ending up in the same end sort of database or end sort of sink, to Alex's metaphor, whether that data actually needs access like across chain during transformation. Because the latter is much more complicated, because then you do need that synchronization. Whereas if it's really just that you want to dump timestamp data where those timestamps might originate from different chains into one database, that's a different challenge. So yeah.
Well, I mean, you answered it pretty well, Derek. If that's not clear, I mean, you can punch in another question there. But it's true, because we're not dealing implicitly with the load layer. You can funnel 3 chains into one database. You're responsible for the load layer. Eventually, maybe we make some well-used, use case as part of the network, so people can offload more of their infrastructure to, indexers. But as that grows, you feed that into one database, and then you have your potential, join queries that you can do. Does that make sense? You're good at them, man. Okay. I'd like to have any other indexers. Raise your hand. Just punch in. I'm present. Silka. Brain fried, man. 0xsinchi. Daya. Bayer. Makes sense. Okay. Well, we're nearing the end there. I'll give it back to
Amazing. Thank you so much. So, a final opportunity, like Alex said, for anyone to slot in some questions before we wrap up. If anything does come to mind, feel free to write in the stage chat after the chat. I'm sure Alex will stick around to answer any questions. I see some people typing at the moment. I'm going to go ahead and enter some resources into the chat. Go ahead and check out the Indexer Firehose channel, and then also check out the Substreams channel, which was recently created to continue the conversation. So if anyone else doesn't have any more questions, I will take this as an opportunity to wrap up. Thank you so much, Alex. This was an incredible conversation. I certainly learned a lot, and I hope that's true for everyone else who's attended here. And if we have high demand, I'm sure we'll have this conversation again in the future. So please do shout if you found this particularly helpful and want to have another episode like this in the future. So just to wrap up, as we always do, we have a POAP. And so if you attended today's conversation and really enjoyed it, go ahead into the stage chat and please type a +1, and you will be airdropped a POAP for today's conversation. Thank you all, and looking forward to seeing you guys next week. Bye-bye.
Thank you all. Appreciate your time.
Bye. Thank you all.
Thanks, y'all.
Thanks, guys. See ya.